Hello, this is Mike at Gamefromscratch, and welcome back to our ongoing Godot game engine tutorial series. In this particular tutorial, we are going to be looking at 2D graphics and all that that entails. This means we're going to jump into the Godot engine and take a look at how the 2D view works. First, we're going to start by creating a sprite, and next, and probably most importantly, we are going to look at how coordinate system works in Godot itself. This means understanding how the view works, how viewports work, etc. Don't worry, it's not a scary subject, but it's something you do need to know to go on. I will assume that you have gone through all of the prior tutorials at this point, so if I cover something that you do not understand, please go back through the previous tutorials. If you do that and you find I've covered something or I've skipped over something and I've assumed that I've covered it, please let me know and I will try to address that. Additionally, every single thing that I cover here, I do both in video and text form. So for previous tutorials, there is a text version available, and the text version of this one is actually already available on Gamefromscratch.com. There will be a link in the comments at the bottom here, so if you want to go through the text version, covers most of the same stuff, possibly in a slightly different order, please do so. Additionally, there are tables that show the hotkeys that are available in the 2D editor. I'm not going to cover them in the same level of detail in this video, so if you need that reference, do be sure to check that out. So it'll be linked in the comments below. So let's jump on in. This is a brand new empty project that I've already created. There's nothing in it at all. And let me just switch over here to the 2D view. 2D view is where you go about laying out your game world. You can see something here. If you've done high school level math, this should be familiar to you. This is actually the Cartesian Plane. And what we are right here is we're in the negative y and positive x quadrant, down the lower right quadrant. A lot of graphics, especially with the OpenGL coordinate system, they normally are actually up here. So the coordinate value, this is your origin, your world origin. The coordinate value 100, 100 would be right about here, say, and then 500, 500 would say be here. In this case, we're actually, and that is still the case behind the scenes for the Godot engine as well, but we are using something called a viewport that abstracts that away from us. And this blue rectangle right here is that viewport. So instead, it is origined right here. So the coordinates 100, 100 within the viewport would be right here. And don't worry, this will all make sense very shortly. Now let's go ahead and start by creating a sprite. A sprite is just a node with a graphic representation and spatial information to tell it where to define itself in the world. Things like rotation, scale, and position. Now let's just create one now. And it's a sprite. Let's filter that down. You'll see there's a couple of different kinds. We're just going to go ahead with a normal sprite, like so, and create it. And default, you can see it's this little blob right here, but let's go and add some more. Oh, let's add a graphic to it, so it's actually got something to show. There are two ways to go about doing this. First off, you can go ahead and import it right here as a 2D texture. You don't actually have to do this. You can just drop it within the hierarchy of your project itself. Which is what I'm going to go ahead and do here. There's actually a bit of a bug with the 2D texture. It comes out all warped and positioned wrong if you use the import. So I'll just do it this way. And I created these for a different tutorial, but I'll just go ahead and use one. And just find your projects directory. Oops. Let's see, it's temp sprite demo. So like so. Just drop your image file in. All right. Again, you could have imported it using import, and that then will copy the file in for you and create a .tex file, but you don't have to do that. You can just do it this way. And then over here in your sprite, just go down to your texture and drop it down and pick load. Grab your file like so, and boom, it's automatically positioned. So we have just now added a sprite to our world. You'll notice there's this lattice around it. This can be used to resize in different directions as you want. And then anywhere within, clicking the left button, you can now position. The very key thing to notice, and well, here I'll show you two things at once. First off, you can use your scroll wheel to zoom in and out, like so. And you can use your middle mouse button, which in my case actually happens to still be my scroll wheel, to pan, like so. Anyway, so I zoomed in, and you see this nice little reticle right here. That is your, I call it a pivot. A lot of game engines call it a pivot. In Godot parlance, it's called an offset. And that is where all positioning is set relative to. So let me just show you something when I move this guy around. I'm going to move this guy within the viewport. And you'll notice right now, this image itself is 128 by 256 pixels. And right now, we are about half of that in. So this value right here, if you look at the positioning, let me just resize this slightly, is at 100 and 160. So I'm going to go ahead and set these back to 0, and you can see what happens. 0, enter, 0, enter. Boom, we're right back to the center of the world. And we're back to the center of the world relative to that reticle itself. So as and to the parent. So now as I start moving this guy around, so left click and drag, I'm moving down a little bit. Well, look what happens to the coordinates. They are all done relative to this pivot point or offset point. That's a very critical thing to understand. That offset port is very important. So when you do transforms, your transforms are relative to it. If you want to move it around, you can. And let me just, I'll show you that later on. Now, let me just drag this guy in, and we'll show you some operations that you can actually perform on this guy. Those is, we've been doing them down here using these values as position, rotate, and scale. However, it's just as easy to do them in code, and let's do that. Let's browse a incredibly poorly named my script and create it. All right. So very first thing, let's show. Get the position. Her position equals, and again, I have a tendency to use self for accessing member variables or member functions. You don't have to. This class itself inherits from Sprite, so therefore you have access to all of the different member functions and member variables that are exposed to Sprite and all of the various other objects that inherits from. So canvas item, node, 2D, etc. They're all available to you using like just get, see, they're there. I have a knack for just doing .self, exact same result. I find this a little clearer, but you can omit the self if you don't like using it. If you're from a C++-esque language, self and this are basically comparable. So I want to do get position, like so. Oh, wait, that's not what I want to do. What I want to do is go ahead and get the parent's position. One thing to understand with a scene, here's our hierarchy. So far, our scene consists of just a sprite. You inherit your parent's positioning, and at the very root of all scenes, it's not shown on the scene display, and it probably should be. It actually would probably make more sense if it was there and you couldn't edit it. But at the very top of the scene hierarchy, there is a node called viewport, and the viewport is what is controlling what is available on scene. So the parent of every top-level scene item is going to be the viewport. So I'm going to go ahead and do self.getParent. And we'll just get its dimensions. So get, that's a method, oops, .get rect, and then size, and then half of its width. This is actually a vector I'm creating. Built-in class, so no need for newing it. So let's do that. All right, and we want to do the same thing, get the height. Height, div 2. All right. So what this value here is going to return is a vector2 centered to the middle of the screen. Now let's just go ahead and move ourselves to it. So self dot and it's set position, and then we will set it to that position. All right. So I need to set my scene up. We covered all this in the oops, gotta save it first. Scene, save scene, sure. Scene, set scene. Alright, so we're setting our scene as the run scene, and now we go ahead and run it, and boom, we're moved to the center. Alright, so that is how translation works. It's a matter of calling set position. Now let's take a look at scaling. Very similar, self.set scale. Oh, sorry, set. We're going to look at rotation. Set rot as in rotation, and then you pass in the amount you want to rotate by. One thing that could throw you off a little bit here is that the value being passed in is actually in radians, and you probably want it to be in degrees. I know I think in degrees, I do not think in radians, so you can easily convert. There's a built-in function called degree to radians. There's actually one for radians to degrees as well, but this is now going to say rotate by 90 degrees. If you go ahead and run it, you'll see, boom, we are now turned. Okay, and then finally we can go ahead and scale it like so. Vector 2, and scaling is by magnitude, so we are going to double it in size. So I want to do 2 and 2, Each one, we could scale it, like we could squash it or stretch it by only scaling in one direction, but we're going to scale it equally to twice as much in both directions, like so. So now go ahead and run that, and you'll see we are now twice as big. Now this might seem slightly unpositioned to you, but that's actually due to the white space in the graphic we're using for our texture. And let me just go ahead and show you how that works, and show you another thing while I'm at it. There's a set of virtual overrides that you can inherit and override, and like we've done here with ready. Ready is being called when your node is created and ready to go. On top of that, there are other ones, such as the one we're about to use, draw, and this is called when you are being drawn. And you can actually Node 2D has a number of helper functions in there for doing. You could do for debug drawing, etc. And that's exactly what we're going to do. We want to draw a rectangle around the boundaries of our image. We do that with self.draw_rect. Now these actually have to be called during the draw method to work. Self.getItemRect. So we're going to get our own dimensions, and we are going to draw it using the color blue, full blue, and 20% opacity, like so. So now when we go ahead and run this code, you'll see there is the outline of our image. And this is just because our image itself has a bunch of white space. I should still have it open here, and I can show you this way. Oh, that doesn't help you much. This is all empty white space. So that's why when we did the rotate, it is being done about the center, but it doesn't necessarily look it because of the way that the actual image is saved. So there you can see, it is centered, it is rotated, and it is scaled 90 degrees. Oh, sorry, it's rotated 90 degrees, and it is scaled to double its size. With the scaling, again, you could also go down. So here's half the size, like so. Okay, so that is programmatically altering the positions of a sprite. Very handy stuff. Now let's go back to the 2D layout for a bit. This is a very important window. This is where you're going to spend a lot of life if you're working on a 2D game. And this is where you organize your world, you lay things out, you add sprites, or other different kinds of nodes, and you assemble your world in general. One very key and useful feature here is something called snapping. Let me just go ahead and show you that. It's in the edit section, so go use snap. You see this really tight grid of, well, it's a grid. So a grid of cells appears. Let's make it slightly less big. We're going to make them 32 by 32. So each one of these squares is 32 units, or 32 pixels in size. All right. So now let me go ahead and turn snapping with turning it on. If I grab this guy and I go to move it, notice what's happening is it moves in increments of the snapping grid. Now, if you're working on a tile-based game, this is invaluable because you're going to probably want things to line up perfectly, and this constrains your movement amounts by the snap amount. Very handy feature. When you're done with it, once again, you can turn it off, and now I can position myself however I want, as you can see. But now snapping's on, it automatically moves you in your snapping unit increments. Very handy. So that's the snapping. Again, I covered a lot of the hotkeys in the blog post. You could go there and see them. But three really critical ones to understand are Q, W, and E, or select, move, and rotate. Select is simply that, select and deselect mode. You can also deselect by hitting the escape key, but when you select a node like this, you can just hit W. W will now put you in move mode, so left click and then drag will reposition. As you see, you're updating those values over here in the inspector, so you could also numerically enter them if you want, like so. And again, rotate or E, so W for move, R for rotate, and then you can rotate, like so. Control Z, undo. And finally, you got pan here. Pan is for moving around your scene, as you can see like this. You can also pan, I think I may have mentioned this already, but using your middle mouse button and scroll using your mouse wheel. So as your world gets bigger, you pan around it using this guy. Again, this rectangle right here represents your viewport, or what is available to you. And let's talk about that for a second. A viewport, again, as I said earlier, it is the top level node in your scene. So in this case, you have one sprite. Its parent is actually the viewport. But what is setting the viewport? What is setting this rectangle right here? Well, that's a very good question. If you go back over here to the project settings, you will see. It's being set right here by these two values. So if instead you would rather have it be 720 by apparently this is being fixed, not a moment too soon. You have to hit enter after doing an edit. say 720 by 480, enter. All right, so there you go. And I close this. You will now see the viewport updated accordingly. There's a number of other key settings in here to be aware of. Some of them are only important to the desktop itself, like this guy right here is toggled. Resizable, if I click that guy off and then run it, I can no longer resize the window, like so. All right, and let's go back for a sec. Make sure we're stopped. And settings. In addition to the resizable, turn that back on, you have a couple of values that are only important to mobile. Orientation, obviously. There's no landscape or portrait mode on desktop, so those are obviously ignored on a desktop. You got touchscreen emulation, very handy little feature. We'll talk about that later on down the road. Another key kind of set of features here are stretch mode and stretch aspect. And this is going to be how Godot handles when you're running on a resolution other than what's available. For example, when we're dealing on a desktop, it can just create the window of whatever size it needs. That's the nice thing about a desktop. You can create windowed versions. So if I created a window that was 384 by 196, it'll do it. That's just going to be a subsection of the screen. However, on mobile devices, your apps are generally 100% of the screen. And this is going to determine how it scales up or down to match that resolution it needs. It's something we'll cover down the road, something to be aware of, but it is set here. So this is what is controlling your viewport. Your viewport is a very critical thing to understand. Another critical thing to understand is this this offset I was talking about earlier. Remember how this is the offset for our viewport. It's not marked with anything, but it is important because your child inherits the coordinates from its parent. And the best way I can show this, first off, remember this code right here? All done there. Let me just go ahead and get rid of the scale so we can see it a bit better. But all this translation code, let's just, we'll just comment that out specifically. There we go. All of this code right here that does all of our movement is being done relative to that offset. So when we're saying rotate 90 degrees and translate from here to here, we're doing it about the center because that is where that offset is set right now. So go back to the 2D view and I'll show you what I mean. Select there, that guy right there is set. So we can go ahead and move it. There's two ways to move that, and it will cause all of our translations to move as a result. The first one you can do, a little buggy at times, but with the movement mode on like this, if you hold down V, the V key, and then move, there, all right, like so. So basically you got to start moving and then hit V. But you'll notice the image itself is moving, but the pivot is not. And let me just put it at the bottom left corner, like so. Okay, so now all of our, and if we look at here, our offset is set to 63 and minus 126. As I told you before, this image is 128 by 256 in size. So what this is taking, this offset is set relative to the center point of your node. So we're saying minus 126 and over 64. Let me use the exact numbers. You can edit them here. Like so. To set that pivot. Okay? And that is saying our pivot is now right there. We could also do, oops, I suppose that should be 128. Now let's show you using a positive value. Our pivot instead becomes up here. Okay? So that is the effect. Now we want it to be the bottom though. So this entire coordinate is relative to the middle of our node itself. And this is setting where the pivot is going to happen relative to. So let's go ahead and run our translation code and see what the difference is. See how it happened? It's not being done centered about the middle anymore. So our rotation is actually happening relative to the bottom left corner of our sprite, as is our translation. And again, if I go back here, and I change this guy to the opposite corner, like so. All right, so now the pivot's done relative to that corner. When we do our transform, boom, you can see the immediate result. Okay, so this pivot is a very key thing to get. It is where things happen relative to. And on top of that, it's even more important to understand because it's inherited down. When I said earlier that the viewport's pivot is right here, even though you can't see it, this is a key concept to get, because let me show you how inheritance works in layouts. Let me just set the pivot back to the center of our sprite. Stupid enter key bug. 0, enter, 0, enter. Okay, so our pivot is now about the center. And let's just position this guy right about here. Okay, so now what I'm going to do is go ahead and I'm going to add another sprite, identical sprite, but as a child of our existing sprite. Right, like so. Go ahead and load it. Like so. Okay. And this guy is now positioned at 0, 0 relative to 0, 0 on this sprite. So this is a little confusing because they directly overlap, but let me go ahead and move it. So this is child 2 that I'm moving, and you'll see I'll move it right about there. This guy's position, that 120 and 244, is relative to the pivot or the offset of the parent. So there to there, so from literally there to there is what is represented by this positioning. So the cool thing is the inherited, all of the positioning and scaling and such is inherited down to children. So I move this guy and everything moves accordingly. And it is done by the pivot. So I'm going to grab this guy and I'm going to move its pivot so that it's down in the bottom corner. And as you can see, if I go back to this child here and I set his position to 0 and 0. Keep in mind his pivot is still about its midpoint. So when I do this, snap, it automatically comes. See, its position then becomes at the pivot of the child. So this relationship is very important to get. The pivot is where all transformations are relative to, but you automatically inherit your parent's positioning. So your positioning is all relative to the container you're in or to the node you're parented to. So this guy is parented to the viewport itself, the top level node. So its positioning right here is all set relative to this point. So I move him to, where is his pivot? Oh, his pivot's down here. So that should basically be 0, 0. Let me see. Yep, 0, 0. And it's all done your pivot point to your parent's pivot point. The confusing thing to get at first, but it is important to understand. And again, when I move him, you'll notice the child moves, but you can move the child independently. And once again, the child, all of these positions are set relative to the parent and relative to the parent's pivot or offset. So as this changes, so too does this relationship. Very key thing to get. It's pretty easily mastered, but these hierarchies, these inheritance trees are very important. You do inherit all the positioning information from your parent, but you are not tied to it. So you can select a child and move it independently, but when the parent is moved, so does the child. Okay, so that basically covers it all. Let me do a quick recap of what we covered here today. Again, there is a text-based version of this. It does have some of the hotkeys that you can use for working with the scenes. For example, I didn't touch on the fact that you can use your arrow keys to do fine-tune movement, or the shift arrow keys to quickly move things around. There are a number, or you can do, see, it's Control P or Control F. F to frame selected, so it automatically snaps in, etc. There are a number of hotkeys you can use in the 2D view for composing your world. They are on the blog post. Check it out. You can probably learn a little bit more than what we covered here, but this is the basics of it. So once again, your 2D world is edited within the 2D panel here. You position your things as you need. If you need to have fine-tuned control over how they are laid out, be sure to make use of snapping, which is available in Edit. You set the snapping size, which is the number of pixels per square in the grid, and you will automatically snap to them as you move around. It allows you to very nicely lay out and precisely put things together. In this case, we made a sprite. A sprite is an image with positioning information. as you see before you. Then we looked at actually parenting. Coordinates are inherited from the parent, and the offset or pivot is critical. That is where rotations happen relative to, and they also determine where the position of the children is relative to the parent. The top level node in the scene is the viewport, so anything you add at the top, such as this sprite, is automatically parented to the viewport. You can get that by using get_parent. There is also a comparable function called get_viewport_rect. Exact same effect. It's probably the better one to use, to be honest, because that works regardless to if the viewport is your parent or not. But you saw here in code, you can easily translate and scale and rotate just by calling set POS, set ROT, or set scale. Again, rotation is in radians, so you need to convert. You can do that using degree to radian. One other thing that we briefly touched on here is you can do some further drawing customization by overriding the draw method, like we did here to draw our own bounding box. Those are in, so you basically just override draw and do the drawing you need to do, and it will be done automatically. That's about it. Oh yeah, your viewport. Your viewport is set in the project settings. It controls what is displayed on screen at the time. There are some advanced settings we did not cover today, but you can specifically set your resolution, resizability, full screen orientation, etc. Using the project settings of your scene. Your viewport is your top level node that all other containers inherit from. By default, the viewport's world starts at 0, 0, which is the top left corner of your screen, and goes down. However, the world itself uses the standard coordinate system, so when we get into 3D, that might feel a little bit different, but don't worry about it for right now. Let's see, that's about the extent of it. Hope that was useful. Oh yeah, I guess I didn't cover on this. Your nodes inherit their the pivot and positioning information from their adult. Very important to create those hierarchies as you want. As you move the parent around, the child will then move accordingly. However, the child can be moved independently. So that's the basics of graphics in 2D graphics in Godot game engine. Coming up, we're actually going to touch on input next, but then we'll jump back into some more advanced graphics, things like animation, texture atlases, etc. But I hope you found that useful. It's a good foundation of what we need to cover going forward. Thank you very much. Goodbye.